Hello, and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of dilations. This is standard 8.3b in the great state of Texas. We are using item number 11 of the 2023 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. All right, so we have this quadrilateral LMPQ is being shown here, and it's going to be dilated to create a new quadrilateral LMPQ prime, and it's going to be dilated with the origin as the center, and then it's got this rule right here. All right, so what does all of this mean? We need to find a true statement. Well, we need to know the difference because we've been dealing with types of transformations for a while here, and when we're dealing with transformations that keep your congruence, okay, we're talking about rotation, right? So sometimes we'll rotate something 90 degrees, we'll rotate something 180 degrees, 270 degrees, we'll algebraically represent it. But it keeps congruence. So you're taking the exact same shape and you're just spinning it around, right? Like that. Then you have reflection. So reflection is when you flip it over the x-axis or the y-axis, and it kind of just flips like this, or it flips like this. And then you have a translation, right? That's when you just slide it. So you slide it to the left, you slide it to the right, you slide it up, you slide it down. These all keep congruence. We're not dealing with one of those, okay? We are dealing with dilation. So when we have a dilation, it doesn't keep congruence, okay? It's going to shrink it or it's going to grow it. And so that is going to be very important, and that's something that we're learning here for the first time in 8th grade is what does it mean to be dilated, right? So you get bigger or you get smaller. So we have this rule right here, okay? We have the LMPQ that's on the screen here. And we see it's going to be 3.75 times x and then 3.75 times y. So this is going to be this 3.75, right? That term is called a scale factor. So we're going to scale it. It's going to be 3.75 times bigger. So what this means is, let's just take p for example, okay? So p has an x-coordinate of 6, and it's got a y-coordinate of 2. So if we wanted to find p prime, okay, so if p equals 6, 2, well, p prime is going to follow this right here, okay? So it's going to be 3.75 times 6 as my x-coordinate, and then 3.75 times 6 as my y-coordinate, which is going to be a lot bigger, okay? Okay, so we can't graph that on the graph that they've provided for us. But this would be my x, 22.5. This would be my y, 7.5. And that's just p, way off the scale. We would do that for m. We would do that for q. So it's going to go way up here. This is going to go way up here. That's going to go way down there. And that's going to go way down there. So it's going to get huge, 3.75 times larger. So knowing all of that, let's look at our answer choices here. Okay, so the angle measure of quadrilateral will be 3.75 times the corresponding angle measure. Well, when we dilate something, we mess with the side lengths. Even though it's going to be 3.75 times bigger, the angle measures always stay the same. Right? If a small square and a huge square still have 90-degree angles, so it's not this one. And then we've got the angle measure will be still asking about the angle measure. Now the side length, that's what we're dealing with. So is it going to be 375 times or 375.75 more? This is a plus 375. And this is a times 375, and we did multiply by 375. So our answer here is going to be C.